In this video, we will talk about how to use design patterns in software development, so make sure to watch the full video. Design patterns are essential tools in software development, providing tried and true solutions to common design challenges. By offering reusable templates, design patterns help developers create systems that are more efficient, scalable, and easier to maintain. Whether you're dealing with object creation, structural relationships, or behavior management, design patterns can streamline your coding process and improve software architecture. Implementing these patterns can also enhance communication within development teams by providing a common language for problem solving. In this guide, we'll explore various design patterns, their purposes, and how to apply them effectively to build robust and flexible software systems. 1. Understanding design patterns. The building blocks of software design. Design patterns are reusable solutions to common problems that software developers face when designing systems. These patterns provide a proven structure that helps guide developers in building scalable, maintainable, and efficient applications. By using design patterns, you can avoid reinventing the wheel and instead apply solutions that have been refined and tested in various projects. Understanding design patterns is key to improving the quality of your software architecture, enhancing communication among team members, and fostering best practices in development. They act as a toolkit that developers can rely on to simplify the design process and avoid common pitfalls. 2. The importance of design patterns in streamlining development. Design patterns play a crucial role in streamlining the software development process by providing standard solutions to recurring challenges. They help reduce complexity and make systems more modular and easier to manage. By applying patterns, developers can focus on solving new problems rather than spending time figuring out how to structure their code. Patterns also make code more understandable and predictable, which enhances collaboration between team members. Furthermore, design patterns provide a clear framework that speeds up development, ensures consistent coding standards, and facilitates the process of adding new features or refactoring existing code without introducing unnecessary complications. 3. Creational design patterns. Efficient object creation techniques. Creational design patterns focus on optimizing the process of object creation, ensuring that systems are flexible, efficient, and scalable. These patterns help developers control how objects are created, which is crucial for resource management and system performance. Some of the most common creational patterns include the Singleton, factory, and builder patterns. These patterns provide mechanisms to encapsulate object creation logic, minimize dependencies, and improve the reusability of your code. By using creational patterns, you can ensure that your system remains adaptable and can handle varying object creation requirements without compromising on performance or maintainability. 4. Structural design patterns. Simplifying complex relationships. Structural design patterns are used to define the relationships between different classes and objects, making it easier to create flexible and efficient system architectures. These patterns focus on composing objects or classes into larger structures, allowing for more robust and maintainable code. Examples of structural patterns include the adapter, bridge, and composite patterns. These patterns are essential when you need to manage the complexity of class hierarchies or object compositions. By simplifying these relationships, structural patterns reduce the need for tightly coupled components, making your system more modular and easier to extend or modify without disrupting existing functionality. 5. Behavioral design patterns. Enhancing object interaction. Behavioral design patterns focus on improving communication and interaction between objects, defining how they cooperate to perform tasks in a clean and efficient manner. These patterns help manage algorithms, responsibilities, and communication between objects while minimizing complexity and dependencies. Examples include the observer, strategy, and command patterns, which provide solutions for handling dynamic interactions between objects. Behavioral patterns are crucial in systems where objects need to collaborate to complete tasks. By applying these patterns, developers can create more maintainable, flexible, and decoupled code that allows objects to interact seamlessly without introducing tight coupling or convoluted logic. 6. Singleton pattern. Managing a single instance efficiently. The singleton pattern ensures that a class has only one instance while providing a global point of access to it. This pattern is particularly useful when managing resources like database connections or logging systems, where only one instance of the object should exist. By controlling the instantiation process, the singleton pattern avoids unnecessary duplication, reduces memory usage, and ensures that only a single, consistent instance is used throughout the application. However, developers should use the singleton pattern with caution, as it can sometimes lead to unintended consequences, such as making systems harder to test or creating hidden dependencies. 7. Factory pattern. Flexible and scalable object creation. The factory pattern provides a way to create objects without specifying the exact class of the object that will be created. This is particularly useful when the type of object to be created may change or when the process of object creation is complex. The factory pattern promotes loose coupling between classes by abstracting the object creation process, allowing for more flexibility and scalability in your system. It also makes the system more modular, as developers can easily add new types of objects without altering existing code. This pattern is widely used in frameworks and libraries to manage object creation in a clean, maintainable way. 8. Observer pattern. Managing event-driven systems. The observer pattern is ideal for scenarios where multiple objects need to be notified of changes in the state of another object. It defines a one-to-many dependency between objects so that when one object changes state, all its dependents, observers are notified and updated automatically. This pattern is commonly used in event-driven systems, such as user interfaces or real-time data processing applications. The observer pattern helps decouple the subject from its observers, making it easier to add or remove observers without affecting the core functionality. By using this pattern, developers can create dynamic systems where components respond to changes efficiently and cohesively. 9. Decorator pattern. Adding functionality dynamically. The decorator pattern allows developers to dynamically add new behavior or functionality to objects without modifying their original code. This pattern is particularly useful when extending functionality in a flexible, reusable way. Unlike inheritance, which adds functionality at compile time, the decorator pattern adds it at runtime by wrapping objects with additional layers of functionality. This enables developers to enhance objects' capabilities without altering the underlying class structure, promoting greater flexibility and scalability. The decorator pattern is often used in user interface libraries and input/output classes where dynamic customization is required, making it a powerful tool for clean, modular development. 10. Choosing the right design pattern. Best practices for effective implementation. Selecting the appropriate design pattern is crucial for solving specific software design challenges effectively. Not every pattern fits every situation, so developers need to evaluate the problem at hand and choose the pattern that best addresses it. Understanding the strengths and weaknesses of each pattern is essential, as using the wrong one can complicate the system rather than simplifying it. Best practices include identifying the problem clearly, understanding the core principles of relevant patterns, and considering future scalability and maintainability. Proper implementation of design patterns improves code quality, enhances flexibility, and ensures that the software remains robust and adaptable as it evolves. Using design patterns in software development is a proven way to enhance code quality, maintainability, and flexibility. By implementing patterns like Singleton, Factory, Observer, and Decorator, developers can address common challenges with established, reusable solutions. Design patterns not only improve the structure and efficiency of the software but also simplify communication within teams by providing a shared framework for problem solving. They promote cleaner, more scalable code, which is easier to extend and modify over time. As you integrate design patterns into your projects, you'll find they contribute to building more robust and adaptable software systems that stand the test of time. What do you think of our video? Let me know in the comments section below. If you enjoyed this video, make sure to hit that like button. Also, subscribe to our channel before you go.